All right, hey guys, welcome back again. Evaluate and simplify algebraic expressions. Evaluate and simplify today. All right, to do that, you got to go to order of operations, which I'm assuming you know already. 4 steps basically when you're simplifying an expression. Always do your grouping symbols first, powers, exponents next, then you multiply, divide from left to right, add, subtract left to right. Hear people say all the time, please excuse my dear Aunt Sally, as a way to remember it, PEMDAS. Parentheses, exponents, multiplication, division, addition, subtraction. Just make sure you remember these 4. You got to go left to right, not the way the PEMDAS says. All right, a couple more words here before we get started. A variable. You know what that is? It's a letter, usually X, N is a lot, A, B, used to represent one or more numbers. An expression, algebraic is a great word. An expression that involves variables, and there's no equal sign. That's how you can tell the difference between an expression and an equation. This is an example of an algebraic expression here. It has variables in it. No equal sign. It's an algebraic expression. A few more words. I keep thinking we're done with the words. Terms. This is called a trinomial. We'll get to that later, but this is made up of 3 terms. This term, and the -7. The -7 is called the constant term because it has no variable. The other ones are called variable terms because obviously they have variables. Coefficient should be a familiar word also. Coefficient is the number right smack in front of the variable. This 3 is a coefficient. The 5 is a coefficient. And the last word is like terms. Like terms, 2 things they have to have in common. They must have the same variable, and if they have an exponent, the exponents must also be the same. 4x and 5x are like terms. They both have x's built to the first power. 5x squared and -7x squared are like terms because, again, they have the same variable and the same exponent. The deal about like terms, they're the only kind of terms that you're allowed to add and subtract with each other, and that's what we're about to do. All right. They're going to give you some problems today that say evaluate an expression. They're going to give you a value for x into the expression. So what we're going to do first is we're going to substitute that value into the expression and for the x's, just like this. Again, sorry about the handwriting a little bit. Now go through order of operations. First thing you do is exponents. So I'm going to do the -3 squared. -3 squared is 9. -6 times -3 plus 11. Then you do multiplication and division from left to right. So my multiplication is here. And also that's -6 times -3, which is +18, going left to right, plus 11. Then I'm going to add and subtract left to right. If I add -36 and 18, that's -18 plus 11, -7. So make sure you got your order of operations there. Not very difficult, just plug in the number for the variable. One more problem here. You're selling homemade candles at a craft fair for $3 each. You spend $120 to rent the booth and buy materials for the candles. First part, write an expression. Remember the algebraic expression with the variable that shows your profit from selling C candles. There's our variable. So we're selling the candles for $3 each. That means our expression is going to be 3C, which means 3 times C. But it also says show your profit. We had to spend $120 just to rent the booth. So that's going to cost us like minus $120 from whatever we sell to get our profit. So the expression is 3C minus 120. It says find the profit if you sell 75. I'm just going to substitute 75 in for the C. Everybody knows 3 times 75 is 225 minus the 120. And when you subtract that, you would end up with 105. So your net profit, is going to be $105 after you sell 75 candles, subtracted out your booth fee. Evaluate the expression. These are just exponents, just real quick. 6 to the 3rd power is 216. I really did this for these second 2. The next one says -2 to the 6. You got to be very careful, even using a calculator, when it says -2 to the 6th power, because I think when we look at that, we know the exponent's even. Anytime the exponent is even, we always think we get a positive number, which in most cases is true. But this 6 applies for the 2 only. It does not apply to the minus sign. So I'm just going to raise 2 to the 6th power, which is 64, and I get -64 even though it was -2. But it was because it was -2. Number 3 is a little bit different because, the negative and the 2 were both raised to the 6th power. The 6th power there goes for everything in the parentheses. And because it's even, the sign changes to positive, and then you raise 2 to the 6th power, and you just get 64. So make sure you see the difference in 2 and 3 right there. That's going to be important, especially when you punch stuff in your calculator. If you wanted to raise the negative sign or not, you have to use parentheses. The one for simplify, no numbers to plug in this time. This is distributive property like we talked about yesterday. If you distribute the 3, you get 3y plus 6. Be very careful with the minus 4. It is a minus 4, which means it's going to change the signs. So I'm going to make that minus 4y and a plus 28. Now I'm looking for like terms to combine. First thing I see these two, 3y and a minus 4y. 3y minus 4y is negative y. And I also see these two, a 6 and a plus 28. 6 and 28 is 34. And that's as simple as you can get. Those are not like terms anymore, so that's as far as you can go. All right, last slide. We'll do a couple of these, maybe all of them. We'll see how it goes. This first one, again, directions are simplify all day long. Simplify the expression. So I'm looking for like terms. The first thing I see, and I always have to go with the greatest exponent first. I see a 2q squared and a minus 5q squared. If you subtract those, you get a negative 3q squared. And then the other two terms in there, the q and the minus 7q, are also like terms. So I'm going to go ahead and subtract those as well. 1q minus 7q is negative 6q. And there's that one. The next one has distributive again. So I'm going to distribute the 8 through there. It'd be 8 times x minus 8 times 3. And again, there's a negative 2 here in front of us. So I'm going to actually distribute a negative 2. Negative 2 times x is a minus 2x. Negative 2 times 6 is a minus 12. Look for your like terms. There's a like term, there's a like term. 8x minus 2x is 6x. Negative 24 minus 12 is negative 36. That's as far as you can go. We'll do that last one while we're at it. We're here anyway. This is a tad bit different because it's actually using different letters. Not that big a deal though. Those two both have x's. They're like terms. Have a negative x plus a 10x. That's 9x. And also these two are both y's. Have a negative 4y plus a 1y, which is a negative 3y. That's as far as you can go with your like terms. So that's pretty much it. Not too bad, I don't think. We'll work on those in class tomorrow, and I'll see you then.